Next, we study about the all the formulas which we are going to use the AC circuit, and all that formulae come from single triangle. That triangle is known as impedance triangle. Understood? So impedance triangle is like this. It's a perpendicular right angle triangle. Okay. In the base, we'll always take the resistance, and in the perpendicular, we'll always inductive reactance or we'll take capacitive reactance. Okay. And the combination of these two resistance is what? Right? And the angle in this triangle is divided by phi. Understood? Now, if we will apply the Pythagoras theorem, remember the Pythagoras theorem? H square is equal to square plus square. So, what would be the formula? That case, H is how much? Z here. Perpendicular is either it would be XL or it would be XC, or depends. It can be XL minus X square or XC minus square, because it's square, so you can take any term, right? Base is how much? Resistance plus square. Correct? So you will get Z is equal to of R square plus XL minus XC whole. Correct? Any doubt in this? So we got this formula, right? Next one you need to about, remember you have studied in 10th class the sin phi, cos phi and tan phi, right? Can you tell me sin phi is how much? Like this na Pandit Badri har bole. P by H is either it would XL or XC. Okay. If both are there, then we'll consider the difference. If one is there, then we'll consider the same term. H is Z. Cos phi R by Z. Tan phi is XL minus XC divided by R. Correct? So from here, can we get the value for phi? Phi would be equal to how much? Sine inverse XL or XC minus XC by Z. Cos inverse R by Z. Tan inverse XL minus X by R. Correct? Now tell me, any problem, any doubt? Okay. Now this is the impedance triangle. If I'll multiply current with the resistance, what we will get? We will get voltage, right? So now we'll make a voltage triangle from the impedance triangle. Impedance triangle, you remember now? Now one is resistance, this one is XL or XC, this one is Z, this one is phi. Correct? Now if I'll multiply current with all the terms, then it will become a voltage triangle. Yes or no? So I into R is how much? R, Y into R, right? I into XL is the basically voltage drop across inductor, right? So VL equal to I into XL or equal to I into equal to I into Z, right? Angle between is phi, right? So you remember this formula for the numerical purpose, that we the basically applied voltage, or we can say total voltage, right? Here is the voltage drop across resistor, that is I in R. PL is the voltage drop across inductor, I into cell. C is the voltage drop across capacitor, I into XC, right? Like suppose if we'll have the series combination of RLC, the total voltage is V. This one is VR, L, one is VC. VR is equal to I into R, PL is equal to I into XL, and VC equal to I into XC. Correct? Okay. So again, you can apply the Pythagoras theorem in this. Now tell me the value for voltage. After applying Pythagoras theorem, tell me in terms of voltage only, or we can say where is triangle, right? So we'll get V equal to of VR ka square plus VL minus VT whole square. Understood? Now if we'll multiply voltage with the current, then it will be what? Right? So basically, if I'll tell you the power, power is further divided into three categories. Okay? One of the power is active power, another power is active power, and another power is apparent power. Right? Active power is denoted by P, reactive power is denoted by Q, apparent power is denoted by S. Active power formula is I cos phi. Reactive power formula is I sin phi. Apparent power formula is VI. Active power standard unit is watt, that is by W. Reactive power standard AR, that is volt ampere reactive. Okay, and apparent power unit is VA, that is volt ampere. Now, active power mainly will use in the resistive load. Reactive power will mainly use in the L or C component. Apparent power will use in the component of RC, RL. Now, where we will use resistive load? Like our all home appliances are of resistive load. Okay? And where will you use L or C? That is mainly in industry will use. Okay? Now, LOC like heavy machines are there now in the machines. So RLC basically will use in transform. Yeah. So if I draw the power triangle, this it is related to the resistor. So which power is related to the resistive? Active power. Active power is denoted by P. We can mark it here as P. Here it is denoted by inductive or capacitive. Which power is related to the inductor or capacitor? Reactive power is denoted by Q, and here the apparent power is the total power, right? Basically it works according to the Beer energy. Yeah, Beer. Okay, so like in beer, if you are drinking, you'll have 70% of the beer but 30% of the frizz, right? Like this. Just imagine this is your beer in your hand, and this active power which you are this is the beer which you are actually paying for. This is your active power. Okay, and the phrase which you are not paying it but still it is there, so that is your reactive power. Okay, and the combination of both will be the apparent power which you have to pay for the both. So basically the apparent power is the combination of active power and the reactive power. Yeah. Sometimes active power is also known as real power or true power. Understood?